Now I want to pose the question of how would you design, how you would design and conduct an investigation of pendulum behavior. I'm going to tell you that in the process of designing and conducting this experiment, which has now occupied several hours of designing the way I want to communicate it and analyzing and modifying and so forth and coming up with new ideas, I see the process as something like this diagram. In the first place, we got to understand the mathematics, because if we don't understand the mathematics, at least to some extent, we're not going to know what we're doing, and we're not going to be able to interpret anything that we happen to do. Now, assuming we understand enough of the mathematics to at least begin, for example, we pretty clearly understand that as the pendulum gets longer, the period is going to increase. And we also understand that the graph of period versus length is going to be concave down. We established that very early. And we can also establish that we can at least test a graph of period versus length to see whether it might be exponential or power function in its nature. So with all that background, we simply proceed to time a pendulum, okay, for different lengths and create a graph and do the testing. So at the very first level, we actually did that early in the course. So understanding something about the mathematics, at least at the point where we did this in the course, we understood that you can make a graph of period versus length, and there are these power functions that have certain characteristics, and we can test to see if we have a power function. And we can figure out our y factor, and if we're really on top of things, we can use that to figure out the power if the test is successful. But first we have to have data that's accurate enough that allows us to make a decent test. So we have to do this very carefully. Now, what we did in class needed to be refined, because in the first place we were sitting there swinging the pendulum with our hands. In the second place, despite me telling you to use a short amplitude, just gentle vibration, some people were swinging the thing like this. That was okay. You know, we need to have uncertainty in the beginning so we know how to deal with uncertainty. But now we're trying to minimize uncertainty. So the refinement, the first obvious refinement in our design is to take more accurate data. Now, you might or might not realize that if the pendulum is handheld, that's going to tend to have some, not major, but some small influence on its period, as opposed to if it's firmly anchored. So in my design here, I was looking around for some way to firmly anchor a pendulum, and I just happened to notice the air conditioning units, metal, magnetic, and very solidly affixed to the wall. Take a magnet, attach the pendulum string between the magnet and the air conditioning unit, and adjust the length, and then proceed to time. Now there's a little more to it than that. A few more things that I was aware of I'm not going to mention right now, but that's pretty much it. And I did that, and then I got online and found a lap timer. It's not hard to find one. I recommend that you find one that simply works rather than one that requires you to download an installer. That's totally unnecessary. There are plenty of lap timers that just work. You click on the link and there it is, and you start clicking and you get times, and lap times and so forth. Okay, so yeah, I found one of those. It took me less than a minute, maybe a couple of minutes to wade through the ones that wanted me to download an installer. But you know, within the top 10 results of my search, I found one that just popped up and worked fine. Now, I didn't test that timer to see really how accurate it was. I took it on faith that it was accurate, but I think that's something we can pretty much take on faith, especially since we only need accuracy to within 1/10 of a second or so over a period of a minute. So within that uncertainty, I'm confident that we have that. But that's something you'd want to verify. So in the process of setting this up and taking data, I was refining the design of the experiment. I knew that I wanted to do the experiment in a way that eliminated the effect of the way I was holding it, the way I was holding the pendulum. Then, a lot of times when you're designing an experiment, you want to analyze the design because you're not sure how you're going to, you want to nail down how you're going to analyze the results once you get them. So you want to analyze the design and see what things you can change in the design to minimize errors in your results and in your analysis. So I'm not going to talk too much about analyzing the design because the design here is fairly simple and the analysis would be fairly simple. But by understanding the mathematics, you understand how to analyze the design, and that helps you modify your design to get a better and better experiment. Okay, well, and of course, there's feedback between all of these things. Okay, you can run an experiment. You set up and take data. Then you think about the mathematics and what it's telling you about the data. You end up understanding the mathematics better, and you end up better able to analyze your results. I went through several steps in analyzing these results. I'd get a result, I would look at it, I'd ask myself questions. Okay, even though I understand the mathematics and it's relatively simple and I know a whole lot more than I was using, I wanted to think about how what I know relates to the data that I'm taking, to my setup, and to what I'm going to do in the end in analyzing the results. Okay, well, in any case, then I use the mathematics to analyze the results. I get results, and then that often leads to more questions, which makes me think about the mathematics a little more, which can change my design and maybe some analysis in that change in design, and all that can change the way I've got it set up and the way I take data. Okay, so all these things feed into one another. Now, the suggestion I would make to you, because this is an experiment that can be done for a 25-cent washer and a piece of thread, which costs almost nothing if you happen to have thread around, how would you modify this experiment? How would you get better and more reliable and more confirmable results? Okay? And then ultimately, in the process of thinking that through, what sorts of things come up in your thinking as related to the design, maybe the analysis of the design, certainly the analysis of the results, setup and data, and of course in your understanding of the mathematics. All these things work together, and a good experimentalist will consider all these things and implement as much of their understanding as possible as it's relevant to the situation and the ultimate goal. And then, once this is all done, you communicate. Okay, we communicate our results in a way that other people can understand it. Now, I communicated my results in terms of some videos. Also, there's a write-up, as you know, on the website. So that is the process, and I really do recommend that you find a lap timer, make a pendulum, and see what kind of results you can get. Whether you do or not, though, think about how you would do it if you were to do it. Give it some thought. You'll understand this whole process much better if all you do is think about it, but if you actually get your hands on it and do it in some way, you greatly enhance what you can get just by thinking about doing it.